Welcome to our March monthly Kube chat. Today we'll be talking about some new features in Kubecost as well as some new integrations that we have. So jumping right in here. So for today's agenda, I'll give you a brief introduction about Kubecost as well as our speakers for the day. Then we're going to jump into our enhancements that we've made to our GPU monitoring as well as budgets. And then we'll also go into our Granular RBAC and then some new integrations we have. We'll save some time at the end for a Q&A. So if you have any questions, feel free to drop them in the Q&A feature on your Zoom there, and we'll cover as many as we can. We also got a number of pre-submitted questions, so we'll also cover those, a couple of those before we get into some of the live questions. And I did just want to flag to everyone that we are recording this session. So if you cannot stay for the whole thing or want to share it with others, I will send an email out probably on Monday with a link to that recording as well as a copy of this deck. So just in case you're unfamiliar, Kubecost began back in 2019 as an open source tool designed to give developers better visibility into their Kubernetes spend. Now today we're working with thousands of teams from startups to enterprises, helping them monitor their cloud costs, reduce waste, and also just strike that right balance between cost, performance, and reliability. We do operate on all cloud providers, including Azure, AWS, GCP. We also support air-gapped and on-prem environments. So regardless of where you're operating, we can likely help you. And right now we manage over 3 billion, or actually 5 billion in cloud spend. And we work with some really great customers like Coinbase, GitLab, Pfizer, just a few that we have listed there. So yeah, we're excited to share more with you today and hopefully start working with you if we're not already. Not to give you a little brief overview of our speakers, our first speaker today is Joe Dahlquist. He is our principal product marketing manager here at Kubecost. I will say he is actually running late to this webinar because he got double booked for another webinar at the same time, but he will be on here in just a few. But he has a ton of experience in Kubernetes and cybersecurity, open source, you name it. He's worked all across the tech world. I did drop his LinkedIn there if you want to connect with him and chat more about OpenCost or, Kubecost or anything open source. Feel free, and he's more than happy to chat with you. And we also have Chip Zoller. Chip is our product manager here at Kubecost. He is also a prominent contributor across the open source community. He has a ton of experience in cloud native and Kubernetes and virtualization. And fun fact, he actually is an oboist and went to school for music. So he's multi-talented. I also dropped his LinkedIn there. So if you want to connect with him, feel free to reach out. So moving right along, we're going to start with walking you through our new GPU features. So over the past several versions of Kubecost releases, we have been slowly rolling out more and more GPU monitoring features. So we're really just going to continue to expand on that as as we progress, and also as the kind of world of GPU continues to rise. So you might be asking yourself, like, why does that really matter? Well, GPUs, they're really, really expensive. So being able to monitor them effectively is very important, so you don't waste a ton of money for your org. So monitoring GPU usage really goes beyond just the cost control, though there's also other impacts that come with that. So not only are you going to be able to cut your costs, but you can also improve performance, reduce your environmental impact, and really better plan for growth and being able to project future spend. So a lot of the features that we are rolling out are very closely tied to these issues that are on the slide here. And so Chip is going to go into a little bit more detail about what some of the specific features that Kubecost has rolled out can do, and then also provide a demo for you of what those look like in Kubecost. And I will kick it over to you, Chip.
Thank you, Dee. All right, so let's talk about what this actually means. So in Kubecost, we've made some really great enhancements in the last couple of versions, depending on when you last checked in with us. So just to do kind of a refresher, Kubecost is able to look at your Kubernetes workloads and understands not only what they're requesting, but what they're using, and attribute the cost to those workloads on a very, very granular basis, even down to the container. Previously, we had GPU support, that is for NVIDIA GPUs, where we were able to understand that they were requesting GPUs, but we attributed the whole cost of the GPU to those workloads. In the past couple versions, though, we've modified and improved that, and we're going to do that further, as Dee mentioned, by actually attributing only the used cost of those GPUs. And we do that by integrating with the NVIDIA standard tooling DCGM exporter that you're probably using today if you have these devices. And we'll take a look at the usage, and we'll marry up the usage with the devices and find out, since we know what they're costing you, we know what the usage is costing you. And that's really important because it unlocks the ability to look at things like idle, which then, of course, gives you insights into efficiency, and the ability to answer those ever pressing questions, which is help me justify how much we're spending and that we're getting something for it. Well, Kubecost can now do that. Um, and because Kubecost is insanely flexible, you can use labels, you can use controller kinds, controller names, namespaces, basically any way that you can slice and dice Kubernetes resource objects, you can attribute those costs, including costs of the GPUs, back to whatever those teams are. And as we all know, AI is omnipresent. It's only going to grow more so in the coming days, weeks, months, and years. This is really important because you're going to have multiple stakeholders and multiple teams that really need access to these GPUs. And so being able to get insights into what they're using and attribute the cost of just the usage back to teams and to larger groups is really important. And so that's the first thing that we did, is to bring more accurate insights on GPUs and their utilization and marry those up with costs. But we haven't stopped there yet. And we haven't stopped even at the things that we're going to share here. But one of the cool things I'll show is that we're going a step further and we're providing you optimization insights. And that is because we now know what GPUs are out there, what you're requesting them, and what they're using, we can now proactively identify areas for you to save money. And I'll show you a demo of that in just a minute here. And those are things like finding out workloads that are requesting a GPU that aren't using one, finding workloads like your AI training and inferencing jobs that are maybe have requested multiple GPUs, but they're not using one or more of them. And also being able to just converge multiple workloads onto a single GPU by doing GPU sharing. These are all now possible with Kubecost. But in addition to that, which I'll show here, we want to be able to enable a more FinOps journey with these GPUs. And so more broadly, these two abilities combined allow you to, at the end of the day, reduce waste and improve efficiency so that what you're paying for, you're actually getting. And with that, I think that we can flip over and show a demo here. So this is the first one I'm going to show. Now in Kubecost, you will be able to come to a new savings card. And we've done a couple things here. We have a table at the top that is GPU centric. So you might be familiar with Kubecost's ability to show you cost allocations for your Kubernetes workloads and even assets. But this table here on the Insights card will show you only your GPU workloads, not everything else in the cluster. So it holds up a magnifying glass to your broader Kubecost estate and shows you only those that have GPU that have been requested. And so you can slice this up by all sorts of aggregations. You can filter on these just as you would in other areas of Kubecost. And then down at the bottom, we have these recommendations. And so because Kubecost is able to look at your workloads that are requesting GPUs and see down inside of them, almost like X-ray vision, how much of a GPU they're using, what type of GPU, how many GPUs. We can pull out these recommendations and show you opportunities for saving money. So, for example, here, we have come across a container that is only using, on average, 48% of a GPU, and we think that you can share it. And so if you click on these, you'll get some more information on what the name of this is, cluster node, and an additional explanation so that you can really assess and have confidence that this recommendation is accurate and it could end up saving you money. Same thing here with optimize and remove. These are different recommendation types, and you can see the possible savings here. This is a fairly new environment, so the numbers look fairly low, but you can imagine for some of these more powerful GPUs, the more GPUs that you can either optimize or remove. And the more expensive they are, the more you can possibly save here. So we can see here, here's a workload that's requesting multiple GPUs, but it's not using one of them. So we think that you can remove one of those and be able to save some money and wholesale remove a workload that's just GPU squatting. So sometimes you have these inferencing jobs that are out there and they spin up and they do a bunch of AI related training or inferencing tasks and then they shut down, but the container is still running out there. And if you know anything about GPUs and Kubernetes, you know that even though if you're not using it, you're still requesting it, nothing else can use it. So you have these jobs that can queue up in the background that increases the wait time for you to be able to actually get your applications to train and to have those models uploaded. So we can identify workloads like this, and you can see here we're flatlined, so we can just remove this workload and save some money. So that is, in a nutshell, the two of the GPU related enhancements that we have brought in the past couple of versions in Kubecost. And what we're looking at next is to go a step further and to do things like per device level introspection, being able to show details on NVIDIA MIG or multi-instance GPU, AMD GPU support, and a bunch of other things around GPU. So with that, I'll kick it back over to Dee to get us into the next section.
Awesome. Thanks, Chip. So now we're going to go into some of the updates that we've made to collections. So the kind of primary two areas of these updates are for budget controls and idle costs. So I'm going to start with just giving you a little bit of background on why both of those are important before we really dive into the actual features themselves. So for the budget control part of it, obviously this gives teams better visibility into their cloud spending, ensuring their costs don't spiral out. But it also ensures that you have predictable spending. So we allow you to track budgets over time. You can also set thresholds and proactively adjust workloads before they exceed those limits so that you can stay within your limits. And they also just honestly drive better resource optimization. So, teams know their spending limits. They can allocate resources more efficiently. And that also just helps them with, cost visibility and responsibility across their teams. So idle costs are also important because this is going to come from workloads that aren't using the CPU, memory, or GPUs they've been allocated. So without monitoring those, teams might be overpaying for resources that they don't actually need. So one way to identify these idle costs is by tracking utilization metrics. So if a workload is consistently using only maybe a fraction of what its requested resources actually are, it might just need to be right-sized. But another key area to watch is your unused or underutilized nodes. So if your nodes are sitting idle with low workloads, you might be able to scale down the cluster or just move the workloads to a more efficient instance. So with the updates that we have made to our collections here, we're able to just kind of better track some of these to give you that visibility that you need for each of these. And now Chip will give you a brief overview of some of these enhancements that we made, and then we'll jump into another demo of these.
Sure. So Kubecost Collections. So Kubecost Collections is an ability that allows you to marry your Kubernetes costs and spend with your cloud costs and spend into one nice package. And so this is useful where you have a team that has resources or even an application. You can slice and dice this a bunch of different ways, but where you've got components and assets that span both of those domains. Some stuff in Kubernetes, and maybe you've got an S3 bucket and some load balancers and some other things. You can combine those into a collection and have that collection represent the true costs of whatever that unit is. And so again, it could be a team, it could be an application, it could be a person or a business unit. So collections are a super useful thing. And also with intelligent deduplication built in, you're not getting overlapping costs that are in there. We're pulling those things out. So we're showing you an accurate number of what your separate resources combined cost together. But we took that further in the past couple of versions, and we've done things like include idle costs in there so that you can see and even pull those idle costs out. And I'll show you that here in just a second. And also, because these budgets for a lot of folks now are supremely useful, and in some cases, this is sort of the go-to unit, if you will, for how people like to visualize their costs. We want to wrap budgets around those. So Kubecost already had budgets. that included things like alerts for when your budget was over. We've wrapped that around collections. And so now you can have a budget for a collection and have an alert associated with that. Improved cost allocation and reporting. Kubecost already had these types of things, but we've taken this a step further again by wrapping it around collections and being able to report on those. And so without further ado, let's get into what that looks like as far as collections is concerned. So let me flip back over here and go into our collections page. So just a level set, here's what a collection looks like in Kubecost, and it's a combination of different types of costs that are in an environment. You can see I can do different things with it here, but costs in my collection, I've got some cloud resources and I've got some Kubernetes resources. And you can see here, I've got whatever the cost associated with the label of app equals Prometheus. I've also got some resources from cloud, and you can see I've got an account ID and some services that are in here. So you're able to see with this a unified view and even broken down by the items that you've included in the collection. This is what my Kubernetes costs, this is what my cloud costs, and then more details around that broken down by window. And then obviously costs that are not in that collection, you can then add into that collection. So this is just a little overview of what collections looks like and how it can be useful, because you can basically build a recipe, if you will, of custom cost sources and then mash those together. And these will also include idle. So you can rest assured that idle is going to be included in these costs, because that's another important thing. Hey, tell me what these are costing me, but also what's the idle that's included in that. And so if we go now over to look at budgets, we have budgets that are available for collections, and you can see a budget right here. So we've got a budget that is associated with one of those collections. We've got an action to email when the spend reaches a 75% threshold, and then another one when it reaches 100%. So you can create budgets for all sorts of things in Kubecost. We added collections so that now, in addition to allocations and assets and cloud, you can put in a collection, set a cap, set a reset time, choose your collection, and then if you want to have an action with it, then you can have some sort of alert when your collection reaches that threshold. There are settings, of course, that can be tuned, and so if you come down here now, scrolling past the shared costs, you've got idle and collections, and so by default, we're hiding it here, but we can also choose to share those idle costs by node and share them by cluster. And this is complementary to what we already had in the allocations page as far as now different idle splitting mechanisms. So we can share by cluster or separate by cluster and node as well as share by cluster and node. So some nice little enhancements there to collections that make them even more useful. And so would love to hear any feedback on this. We know that collections is a pretty popular piece of capability, and so that's what we've got for you as far as collections enhancements in the past couple versions.
All right, awesome. Thanks, Chip. So next we're going to move into the updates we've made to RBAC. So, this is very, very critical for governance, at any organization. So the reason we implemented some new updates to this is simply for that reason. So with our new RBAC updates, you can get more granular with how you can set those controls, which Chip will walk you through. But it starts with enhanced security. So we are able to limit the access to all that sensitive cost data that you have, and also your infrastructure data, and either denote that by user or by team. This also ensures compliance. So you're able to enforce your least privilege principles to make sure that you're meeting all the security and audit requirements that your org might have. But it also just improves the usability. Like, not everyone needs to have access to all the data. So it allows you to just really show people what they need when they need it without giving them a bunch of data that they don't need to see. Really lets people focus on the data that's most critical to their role. But it also helps with multi-tenant management. So you can control access across your teams while maintaining data privacy, across the board. So now I'll have Chip give you a little bit of detail about RBAC, and then we'll actually walk you through that in the demo environment and show you how it works.
Thanks, Dee. So RBAC is near and dear to many of our hearts. We almost work with it sometimes on a daily basis. The need is clear. You have different stakeholders and different teams and different personas. They all need access to different things. In some cases, that's needing access or not needing access because of privacy concerns. Sometimes it's just there's too much stuff to look at. We're jumping between multiple tools, and we just want to provide a better experience in focusing users down to what they really care about. And so what we've done in the past couple versions of Kubecost is really enhance our RBAC story to provide granular, advanced RBAC with some nice new capabilities that even go down to page, and as you'll see here in just a second, even filter abilities so that you can craft a role and assign that role to a team, an individual, however you'd like to scope that, and have the portions of Kubecost exposed to them and also pre-configured so there's nothing that they need to do. So for example, let's say that you had a manager that was part of the infrastructure team. Manager probably doesn't need to see all of the nitty-gritty details of Kubernetes, but you want to provide him some of the high-level assets and be able to focus on the aspect of the business that they're responsible for. Well, you can now do that in Kubecost. This is an enterprise feature, and if you're using, and it does require SAML or OIDC to use, a lot of teams are already using those. But if you are using those, then we can layer in the Teams RBAC and craft custom roles and be able to filter down to those specific resources. So let's roll on to that here. And you will see in the newer versions of Kubecost, if you go to Teams over here, when you have an enterprise license and you're using SAML or OIDC, you've now got, in addition to the teams that have already been created, you have the now ability to create custom roles. And so let's just walk through what one of these looks like. So I want to create a role to do what I described. I'll say manager, and this is my manager. And we want to be able to provide some read-only access to only certain pages, maybe access to the overview page itself, and then we are only interested in some assets. And so we can uncheck some of these other pages that are here. And maybe we want, let's say, sorry, that's cloud cost. We want to be able to look at an asset type, which is, node, for example. So I can create this as a role and then come in and create a new team. And in my team, this is where we have principals that are your people and your other entities that are out there that we will bind to that role. And this is where we would put in, depending on your setup with SAML or OIDC, you're using a claim. Won't go into a lot of the details on how claims work, but this might be an attribute like manager, and this could be infra or something like that. And so if we save this, we've got our new manager team, which is using our manager role. And so all they need to do now is log into Kubecost, and they won't see all of the aspects of Kubecost, but they'll only see the assets page filtered down to the filter that we defined in the role here. And it looks like my token is probably expired. But that is a little overview of the new Teams RBAC feature here. And so you can see here in my default team, I'm able to see all of the permissions available. And so they can likewise see the permissions that are available to them. So a really helpful and necessary, in a lot of cases, enhancement to Kubecost that allows you to dial in which sections of Kubecost your teams might find useful, both to sort of put blinders on and focus them down on areas that are in their concern, and also because of sensitivity matters. So hopefully that makes sense, and love to get any feedback that you might have on the new RBAC team. So back to you, D.
Hey, Chip, I'm actually jumping in, and sorry to everybody for dropping in on the party late. I was actually doing another presentation. Really excited about this integration that we've launched. I believe it's in beta now, but it's the first integration that we've got between Kubecost and Turbonomic. One of the first problems that this solves is it helps provide some intelligent scaling activities and options for customers. Things like the ability to right size workload controllers based on not data that happened yesterday or over the last week, but based on real-time data, and to adjust things like CPU and memory requests so that you can optimize for cost and performance, not just one or the other. Another great artifact of this integration is the ability to do workload and VM suspension, similar to the way that you can do some automated cluster turndown. With Kubecost, you can suspend things like idle pods and virtual machines so you can eliminate waste, whether that's over a weekend or a long holiday, or just in times when those resources aren't needed to be up and accessible. You can also predict some savings that are calculated using our cost prediction API that would happen in the future. Another is the ability to place pods in a more informed and intelligent manner to be able to dynamically balance workloads, improve efficiency, reduce costs associated with them, and then also reduce idle infrastructure costs by optimizing nodes and the utilization of those nodes by teaming the two solutions together. Last but not least, being able to get all of that visibility in one place, right? To view the savings from Turbonomic actions right within the Kubecost UI. It does require Turbonomic integration to be able to enable those capabilities, but if you're a developer out there listening and you don't want to have to pop back and forth between tabs and windows, this is an integration that helps make your life a little easier. Quick screenshot we've got of the savings cards that are available to customers using both with some Turbonomic actions there that are new. We're not done with integrations that we've just launched. We also have a new integration between Kubecost and Instana. And this is great because you're able to connect the dots between cost and performance data using these two solutions together. One singular view, a comprehensive view of both cost and performance monitoring, so you can look at trends of cost alongside the performance metrics and understand how those two correlate and correspond, and then being able to identify how your spending on resources are impacting application health, reliability, stability, and performance. This integration also enables really granular cost attribution. So if you want to be able to track things like CPU, GPU, network, storage, and load balancer costs, and you want to be able to do that using Kubernetes dimensions like namespaces, labels and tags, or clusters, you'd be able to do that. You can understand in a very granular way which workloads are specifically driving the spend in my environment, and then you can do something about that. This integration between Instana and Kubecost also enables some smart alerting and anomaly detection that Kubecost can bring to the table to be able to understand when spikes in cost happen and then correlate those to performance incidents, perhaps, or to get real-time notifications over webhooks and integrations for things like Slack, Teams, email alerts for budget overruns and anomalous efficiency issues. There's some pre-built dashboards that make this work right out of the box for you, where you can look at cost distribution by these commonality dimensions like namespace and clusters by using some of Instana's included widgets, and then compare spending trends with your historical release markers to understand was this last release that we did our most expensive release ever, or was it perhaps a previous one?
Thanks, Joe. And we aren't going to do a demo of Instana because we don't have a demo environment ourselves to access, but I did drop a QR code here that goes to their docs site. And if any of you would like to learn more about Instana, just reach out to us and we're more than happy to get you connected with their team. But I did drop a few screenshots from the docs site here so you can see how Kubecost is integrated here. So if you see here, we have Kubecost labeled on this dashboard, and you can hover over to see more detail. But if you actually click through that, you can also open up a report that has a much more granular view of the Kubecost specific metrics. And with that, we will shift over to our Q&A. So as I mentioned, we did get a couple of pre-submitted questions that we were going to start with. But if you have any questions about any of these features, or honestly just Kubecost in general, feel free to drop them into the Q&A there in your Zoom, and we will also get to those. But starting with our first pre-submitted question, someone asked how to integrate multiple cluster hybrid Kubernetes.
Sure, I'll be glad to take that. So Kubecost, one of the great things about it is you can install Kubecost on all of your clusters and federate those into a single view. So it doesn't matter if you have clusters that are split between on-premises and one cloud provider, or two cloud providers, or three cloud providers, or all of them. You can install Kubecost on all of those and have them send all of their data to a centralized location, and Kubecost will pick up on that, split it out between the clusters, and show you in the proverbial single pane of glass that we all love so dearly, all of your estate, no matter where it is, what type it is, and have those cloud integrations be correct for that cluster. So that's the other big thing, is not just being able to provide you things like basic public rate cards, but integrating with your bill, regardless of if you're using hybrid cloud, which a lot of folks are. You can have those cloud specific integrations access your bill for those cloud providers and associate with those clusters. So we call this Kubecost Federation. This is available with an enterprise license, but allows you really easy access to seeing all of your costs in one space.
Thanks, Chip. We also got a question live from the audience. Well, more of a comment, I guess. Someone wanted to see if they could have a high-level roadmap of additional GPU features that will be coming out. I'm not sure if you're allowed to share anything looking into the future, Chip, but if you can, that would be cool.
I'll certainly try. So a few things that we want to do. We wanted, and I mentioned a little bit about this earlier, but we want to provide not just information on the workloads, which, as I showed in the demo, Kubecost does today, but we want to go deeper and show this on a per device level. We want Kubecost to understand what these individual GPUs are doing, even if there are no workloads that are using them, or even if there are multiple workloads that are using them in a shared perspective. We want to be able to show and answer the question. You can point a finger at an individual device and say, show me how that device or all of my devices are doing, not from a workload perspective, but from the hardware perspective, the infrastructure. So we want to be able to provide you insights around that. We also want to support NVIDIA MIG, multi-instance GPU. We know that this is a popular technology that is being used and will probably be used more heavily by some of these AI practitioners because it's a way to securely and from a hardware perspective partition a GPU. We definitely are going to do some work around there. We want to support other GPU vendors. AMD is probably going to be next on our list. We're looking at Intel as well. So we want to go deeper in the NVIDIA story, but we also want to go wider. And also some other things that we're thinking about is how can we provide more optimization and more actions that surround GPUs. So a lot more on that story, but those are some of the high level ideas that we're working through today.
Super helpful. I see we got a couple of other questions too. Rajesh asks, how can I get the cost based on an application or the application level in Kubernetes? And it might be this cool collections capability that we talked about.
Yep. So Getting costs based on an application level, I mean, you can do that in a variety of different ways. So Kubecost understands the utilization and it understands the hardware and how much the hardware costs based on what's running on it. So you can get this in what's called the allocations page. And I showed that briefly in a demo just a moment ago, but this is your cost allocation. And you can look at that down to a per container basis if you want to. You can also slice that up by all the different metrics and dimensions that Kubernetes offers, from a cluster all the way down to a label or an annotation. Things like collections allow you to group those into more custom constructs so that you can look at these higher levels and then stitch them across. Either it could be just a collection based on different Kubernetes dimensions. Maybe you got namespace A and label that is Z. You can combine those into a collection. So Kubecost provides the information that's there. It's in a granular perspective and it's accurate. And so how you combine that and how you make your own recipe from the available ingredients is entirely up to you.
Great, thanks, Chip. We had another question from Brajesh. So he asked what metrics to analyze, or what metrics should he look at to analyze the cost of all containerized applications in Kubernetes?
Yeah, it's a bit of a difficult question because Kubernetes is vast and there are a lot of metrics that are available there. But in general, you want to look at things like requests, and you want to look at usage. In Kubernetes, requests function as reservations on capacity. So if you're requesting, let's say, 100 gigabytes of memory, doesn't matter whether you're using it or not, you're going to be sucking that away from other workloads. And Kubecost is going to be able to show you this. But when it comes to a basic perspective, just look at the allocations page. You can see Kubecost, you don't have to tune it to tell it which specific metric to consider. Kubecost is already intelligently loaded with those metrics, and it knows the balance between usage and requests, and it's going to show you the costs associated with those. So start with the allocations page, see what Kubecost is providing you. It's always helpful to connect it to your cloud provider if that's applicable to you, because Kubecost can show you percent accuracy once we get your bill. But take a look at the allocations page, as that is showing you the costs that are associated with those metrics that Kubecost is configured with out of the box.
Thanks, Chip. I'm going to shift gears back over to a few more pre-submitted questions we have. So someone had asked, how do you handle shared cost allocations?
Yep, great question. So in Kubecost, there are a number of different dimensions that you can configure shared costs. Why don't I just flip over real quick and show an example of that? I will give you an example of what Kubecost can do as far as sharing costs. We know that this is super important because you've got all sorts of different levels in Kubernetes where you need to be able to take one cost group and then distribute that. And so here in the settings, we can do all sorts of sharing mechanisms. We can put in an overhead amount. We can have tenancy costs like cluster management fees. So if you're in a public Kubernetes as a service provider, there's cluster management fees that are associated with that. Shared namespaces. So a lot of times infrastructure teams will have common tooling. Could be security tools, it could be CI/CD tools, it could be, chaos or testing tools. Oftentimes those are costs that should be distributed amongst applications and teams because those are all benefits that tenants on the cluster are able to make use of. Same thing with labels. There are multiple different ways here that you can share and distribute those costs so that the workloads that Kubecost is monitoring and showing you the cost information is more attuned towards how you operate. And everybody's different. Kubernetes and cloud is a very sort of personal effort from a lot of companies and teams' perspective. So we give you the flexibility on how you can figure those shared costs. You can do none of it. You can do some of it. You can do all of it. It's really up to you.
Great, thanks, Chip. And then the last question that we had pre-submitted was, how can I use Kubecost for cloud costs?
Sure. So Kubecost wouldn't be much use if it was Kubernetes only. So we provide the ability to pull in those cloud costs and marry them up with your Kubernetes costs. You saw me show a little bit of that in collections earlier, and you saw me put a budget around that. But by virtue of connecting Kubecost to those cloud providers, again, if you're in a cloud, then Kubecost will pull in those cloud resources. It knows how much of those, if any of those, are associated with those Kubernetes workloads. But for things that may have nothing to do with Kubernetes workloads, you can look at those separately and you can slice those by all the different dimensions that your cloud provider offers and then some. So Kubecost is really a holistic tool, not just for very granular Kubernetes costs and how you can attribute those to different levels, but really your entire estate, Kubernetes and cloud, that you can mix and match and then provide with features like RBAC teams to a very granular level to the groups and roles that make sense to you and your organization.
Awesome. Thanks, Chip. Well, we will end a bit early today and give you some time back, but I did want to let everyone know that we will be at KubeCon London happening in a few weeks. So if you will be there, feel free to stop by. Joe and I will both be in the booth along with the rest of the Kubecost team. And we have a couple in-booth sessions scheduled, but we're also available to do personalized demos or, work with you and answer any questions you might have. So if you'll be around, please come see us. And I also wanted to flag that we will be skipping a webinar for the month of April. We are in the process of migrating to a new webinar tool to kind of go along with our migration into IBM. So apologies there, but I promise we will be back in May once we are on our new system. So be on the lookout for an invite for the upcoming webinars we have planned for May and beyond. And yeah, thank you for joining today. It was really great to share all this with you, and thank you to our speakers.